So we're going to do some slightly more difficult sorts of questions. When I say slightly more difficult, these ones, I mean, there is easy work, but these questions are going to be, so certainly towards the end, a little bit more challenging. All right. There we go. Mr. Bavoom has joined us. Spears joined us. Lovely. Welcome, guys. It's so nice to have you here with us. I was just saying to Watobe and Kanyisila, I hope you're feeling strong this evening. We're going to do some questions that are a little bit more difficult, but I think this is really good practice for you for what could potentially be coming up in finals. Okay, so question number 2 says to us, in the diagram below, we have been given a point which has the coordinates 3 and 7, B a point which has the coordinates 1 and -6, and C which has the coordinates -3 and 4. They are the vertices of triangle ABC. Line AC is extended to intersect the x-axis at D. M is the midpoint of BC. ADO is theta, and the inclination of BC is called alpha in this case. All right, so the first thing that they want us to do, let's see if I can move this up here, although I don't know. It's gonna help us. Does that go under or over? No, it goes. All right, let's just leave that there for now, and we'll see what we can do. All right, so the first thing that they want us to do is an easy question, is they want us to calculate the coordinates of M, the midpoint of BC. So they want us to calculate the coordinates of M, the midpoint of BC. So that's a fairly easy question, only worth 2 marks. Can you guys do that on your own? I'll grab a formula sheet for you. Let's just go back here. Sorry, guys. Just get this. I should have. Okay, let's just stick it over here. Sorry, otherwise there's just so much going on the screen all at the same time, which is a little bit overwhelming, but anyway, there we go. All right, so we've got almost everything on. Okay, so the coordinates of M, the midpoint of BC. Can you guys do that? Can you see B? Sorry, can you see there? Of course. There you go. Okay, so can you see Leah's got an answer? Oh, good. There's a whole bunch more that joined us. Hello, Tyler, Thelma, Tahir. Whoever not said hello to Pumeza, Haydeen, Kashandra. Nice to have you guys with us. Okay, boy, Chipple, you got the same answers. Can you see there? Anybody get anything different? Okay, so I agree with you. I got the same answer. I'm just going to pop mine here on the side. All right, so for 2.1, the coordinates at M, the midpoint, we would have gone -3 + 1 over 2. And over here, we would have gone 4 - 6 over 2. And therefore, the coordinates at M would be -1 and -1. And we feel confident about our answer because we can see that M is a point in the third quadrant. So we were expecting a -x, and we were certainly expecting a -y as well. Okay, now the next question says to us, hence determine the equation of the circle having center M and passing through B and C. Okay, so that's out of 4, guys. So they want us to determine the equation of the circle having center M and passing through points B and C. We must give our answer in center radius form, like so. Okay, so now, just move that out the way there. All right, what's the first thing that we should do here? Let's move it down a little bit. What do you think the first thing we should do here is? Okay, so the formula for the equation of a circle, can you see there? Okay, so then sub in the coordinates of M, and then Tisha, absolutely, then we can calculate R, the length of the radius. Okay, so the first thing we're going to do, as Kanisile said, is we are going to sub in, so let's do 2.2 over here. We're going to sub this information in, right? So we're going to end up with x plus 1 squared plus y plus 1 squared is equal to r squared. Okay, so Tisha, your suggestion, we've done what Kanisile said, your suggestion was we now need to work out r squared. How are we going to do that, Tisha? What would you do next? Thank you, Kanisile. Tisha, can you tell me how you would work out r? What would you do, Tisha? Absolutely, Boichepo. Okay, so you can either substitute in the coordinates at C, or you can substitute in the coordinates at B. It doesn't matter. Either or. Okay, your choice. All right, so we're just going to pick one. Boichepo, which one do you want to use? You want to use B. Okay, let's do that. All right. Yes, can you see that? I also saw you left with the square, but it's not the end of the world. So I'm pointing and completing the squares. Okay, so Tisha, we don't need to complete the square in this situation. When we complete the square is when we go from standard form to center radius form. That's when we're completing the square. So we don't need to complete the square here. We just need to work out the value of R. So that's why Boichepo said either we sub in C or we sub in B. We need an X and a Y so that R is our only unknown in the equation. Okay, Tisha? All right, so Boichepo said, let's sub in the B. So we'll do that, Boichepo. In place of X, we're going to have 1. In place of the Y, sorry, we've got -6. All right, and we don't actually have to work out R, we can just work out what R squared is equal to. So what are you guys getting for R squared? What do you get R squared is equal to, Matrix? Indeed. Okay, yes, Pumeza, yes, can you see that? I'm getting this, yes, Butchip, I'm getting the same answer. Okay, 29, I agree. All right, so now they've said to us, hence determine the equation of the circle having center M, Let's just put it all together. So the equation of the circle is going to be x plus 1 squared plus y plus 1 squared, and it's going to be equal to 29. Okay, good, Tisha, lovely. All right, so there we go. We have answered that question. Oh yes, we'll just talk about marks. So here, mark for subbing in, mark for the answer. Here I would say that there would have to be obviously a mark on the answer, a mark for subbing in one of the points, and then maybe the other mark, 1 mark for knowing that we had to do that over there. Okay, so 2.3 now. Let's go and have a look at what 2.3 is asking us. So given that the gradient of BC is -5/2, calculate the value of alpha. So given that BC has a gradient of -5/2, calculate the value of alpha. So what do we do here, Matrix? What do we write? There we go. Lovely, Tisha. Yes, can you see it? Tan alpha equals M. Okay, so tan alpha equals M. Your gradient in this case is -5/2. Now what do we do? A good start. What do we do next? Okay, so Tisha, when you say inverse, what do you mean? Okay, all right. Okay, I understand you now. So shift tan. Okay, so how would you write this? What am I calculating? Am I calculating alpha? Should I write alpha equals? Okay. So no, it's not Mr. Baboon. Boyd Shepherd, you are saying that we should put in the -5/2. What would you do then, Boyd Shepherd? Okay, Sipihle, yes. Sipihle, sorry. 100%. Okay, so I think different teachers teach how to set this out differently. Okay, so Spare, what you've said there is lovely. Okay, I would be very, very happy with that. At my school, we do it slightly differently. What we do here is we teach our children that we are calculating a reference angle or an RA, and we don't use the negative. But if you do want to use the negative, that's fine. We're going to do as you said. We're going to press shift and then tan, and we're going to put in our 5/2, and some of you will be getting -68,1985. If you do it this way, you end up with +68,20. And what's very important is that you then say that alpha is equal to 180 minus 68,20. But if you want to work with negative 68,20 plus 180, there is nothing wrong with that. Okay, so that means that our final answer is going to be, you guys, what are you getting? Let's just have a look in the chat. Okay, Boyd Sherpo, you're not doing a general solution, so you don't have to worry about adding multiples of 360. But the 180 plus -68, that's fine. There we go. Can you see it? That's it, Tisha. It's okay. 6,80. Okay, what's really important here, guys, is that you must not say that alpha is minus 68.20 or 68.20. So as long as you've written alpha equals 180 minus 68.20 or alpha equals minus 68.2 plus 180, that's fine. Okay. All right, lovely, well done. Okay, so because the gradient was negative, alpha, the angle of inclination, is obtuse. All right, so we have to remember to subtract it from 180 or to add 180 to our negative angle. Okay, so how much was that out of? Let's just have a look here. That was out of 2 marks. Okay, so not very much. Here, I suppose there would be a mark for knowing we had to do that, and then for our answer. Okay, well done, everybody. Let's go on to question 2.4 now. What does that want us to do? Calculate the size of theta. Okay, so now this is out of 3 marks. 3 marks for the size of theta. So what do you guys think we should do now? How are we going to work out the size of theta? Gradient of what? Sorry, can you see it? Of AC. Agreed? Agreed? Okay, so theta is the angle of inclination of line ACD. I mean, they did say to us after all that AC has been extended to D and that D is a point on the x-axis. So we do know that ACD is a straight line. All right, so Kanisile, you're quite right. We're going to work out the gradient of AC and then we're going to use that to calculate theta. All right, so also not a particularly difficult question. Let's do that now. Does that make sense to everybody else? So working out the gradient of AC first of all. So our change in y, 7 minus 4 over our change in x. So this gives us 3 over 6. So we get 102. So now tan theta equals 1/2. Good stuff. Okay, what are you guys getting for theta? That's what Kanisile's got. Anybody get anything different? Hello. Oh, my darling. Sorry, my cat's just walked into the room. Yes, me too. Hey, Dean and Tisha, I also get 26,57 degrees. Oopsie, no, come get cat. Come. You can't do this now. You can't do this now. No. Sorry, he's very affectionate. So there we go. All right, I get the same answer. This was out of 3. So again here, we would work out the gradient, tan theta equals m, and there is our answer. Okay, question 2.5 now. Hence or otherwise. Okay. Hence or otherwise, calculate the size of DCB. Okay, so DCB matrix is, let's just come more. DCB is this angle over here. All right, so what are your ideas? How would we work out the size of DCB? What do you think we should do? Go for it, Tisha.
It's possible that we already have angle alpha. We can look for the angle over there. We can say 180 minus the angle alpha. After finding that one, we have theta and that angle. We can look for that one. But is it possible that we can say that angle is 90 degrees because it's very straight line?
Unfortunately, you were breaking up a lot there, Tisha, so I struggled to hear what it is that you were saying. But if you were saying, let's use angle theta and angle alpha, then you're on the right track. Is that what you were suggesting? So if we use angle theta and angle alpha, yes, sorry, Tisha. Yes, that's what you were suggesting. How? What would you do, Tisha? How would you use theta and alpha together to get DCB? Anybody? Tisha's on the right track here. Anybody want to make a suggestion as well? What would you do?
Oh,
There we go, Tyler. Okay, Mr. Bavuma, you can do that. All right. Yes, Tisha, you can do that as well. If you guys have a look, all right, Tyler said, wouldn't it be exterior angles of a triangle? And Tyler's suggestion, while the rest of you are correct, but Tyler's suggestion is going to get you to the answer in the fewest steps possible. Okay, so that was a really, really good suggestion, Tyler. Which two angles added together would give us the exterior angle on the outside, Tyler? How do we use exterior angle of triangle in this case? Okay, so Spear is saying DCB is 118 minus, there we go. Okay, guys, have a look at what Spear has put into the chat. Spear, that's lovely. Okay, very, very nice. All right, so if you recall from geometry, this is our geometry from a long time ago. If we add angle theta over here to angle DCB over there, it's going to give us the exterior angle of the triangle. Okay, so here, there is your triangle. The x-axis is this side over here, and because it's been extended, there is your exterior angle. Okay, so exterior angle is equal to the sum of the two opposite interior angles. Okay, very, very nice. Well done. Okay, so that will be the quickest way for us to be able to answer this question. All right, so 2.5. Now let's do that. Okay, we would say that DCB plus theta is 26,57 equals 111,80. Exterior angle of triangle. And then quite right, we would take 111.80 minus, and what are you guys getting as an answer? Me too. Can you see that? Yes, bear me too. Okay, so 85, comma, 23 degrees. Yes, boy, triple. Lovely. Well done, everybody. That's great. Okay, good work. Nice. So how many marks was that out of? It was out of 2 marks. Okay, so I suppose here there would have been a mark on that line without a reason and a mark for the answer. Okay, good stuff. We are almost there. Okay, so can you see him when I said to you, are you feeling strong today? This was the reason why I was asking if you are feeling strong. Okay, let's have a look at question 2.6, everyone. So here we go. In question 2.6, it tells us that G, coordinates S and T, so S is its X coordinate, T is the Y coordinate, is a point such that T equals 2S plus 1. And GC is equal to root 17. Calculate 2 possible values for S and T. Okay, and this is out of 6 marks matrix. Okay, so what do they want us to do here? What are your ideas? All right, Boyd-Sherpa, yes, we could use distance formula. How? What would you, to find S and T, 100%. Boyd-Sherpa, I'm interested to know, how would you use distance formula? What would you write?
Ma'am, I think that we should, I think that we should, it should be square root, I can say this, square root S plus -3 squared plus 2S plus 1 plus 4 squared. That way we can be able to find the S value and then we'll find the T value by using 2S plus 1 afterwards.
That's a lovely, lovely, lovely suggestion. I like it a lot. Okay, I don't know if the rest of you understood what Boyd-Sherpa was saying, but that was really, really great. Okay, so what Boyd-Sherpa has chosen to do here is to work with T in terms of S. Okay, so in other words, here working with T in terms of S, instead of subbing in T, to sub in 2S plus 1, okay, which I think there's absolutely nothing wrong with that. Okay, so Boyd-Sherpa, what we could do is, as you had said, we're going to use distance formula. Okay, so distance equals the square root, and then here is our difference in our x's. Here is our difference in our y's. Okay, so root 17 would have to go over here. Okay, that is the length of GC. So we've got to work with the coordinates at G, S, and T, and we've got to work with the coordinates at C as well. Okay, so that's where Boyd-Sherpa got S plus 3 from. Does that make sense to everybody? So here, S plus 3. Then what she's chosen to do is that instead of working with T, we can work with 2S plus 1. So we're writing T as 2S plus 1. Okay, and now we've got to put in our y coordinate at C, which would be 4. So now here we would end up with -4 squared. Okay, does that make sense to everyone? Are we all good at this point? Before I carry on, just confirm that you guys are okay with this. Are we all okay? Yes? Sure? All right, lovely. Now, what's our next step? What do we need to do? Is it -1? Okay, let me just go back and go and have a look. It's +1. Okay, spare, but yes, I do sometimes, not sometimes, often make mistakes. But yeah, t is equal to 2s plus 1, not 2s minus 1. But thank you for checking. All right, so what are we going to do to both sides of our equation now, guys? We're going to square them. That's it. Well done. Okay, so we're going to square the left and we are going to square the right. Okay, so get rid of those roots. So that means that on the left-hand side, we will end up with 17 by itself. And on the right-hand side, we're going to end up with s plus 3 squared plus, and then I'm just going to combine like terms here. So this is going to be 2s, and that's going to be -3 squared over there. Okay, and now everything is in terms of s. Thank you, Boyd Sherpo. And now we can multiply it all out and work out our solutions for s. Okay, good job, everybody. All right, so let's go ahead and go and do that. Squaring our binomial, this would give us s squared plus 6s plus 9. Then over here, we would end up with 4s squared minus 12s plus 9. Get it into standard form. So that is going to leave us with 5s squared. Then that would be minus 6s. And then we would end up with 9 plus 9 minus 17. So that would leave us with +1. Is that right, Nelly? Yeah, because it would be 18 minus 17. Hey.
Yeah, that's right.
Okay, all right. And now we need to factorize. If you guys can't factorize, then you could use the quadratic formula here. But hopefully factorizing is not a problem. So 5s and s over here, we have to have 1 there and 1 there. And then both brackets have to be minus if there's a minus in the middle. Okay, so therefore, s is going to be equal to 1 over 5, or s is equal to 1. Okay, so there are two solutions for s. How are we going to get two solutions for t now? What should we do? We've got to go back and use our formula. Okay, so in other words, t equals 2s plus 1. Okay, so subbing back into that, t equals 2s plus 1. Oopsie. And then on this side over here, same thing. Okay, or t would be equal to 2s plus 1. Okay, so t would be equal to 3. And here it would be equal to 7 over 5. If I've done that correctly. Yeah. Okay. Good stuff, Matrix. How do you feel? Everybody happy with that? Good, can you see it? How's everybody else feeling? Oh, you dancing, Mr. Bavuma. Well done, boy chair Paul.
There's like 19 of you. So we should like 19 emojis.
I'm sure you can, Mr. Bavuma. Well done, Spare. Okay, can you see it? You're gonna help him to dance. There you go, Mr. Bavuma. Awesome.
Yeah, as long as you move to a beat, that's all that matters.
Absolutely, absolutely.
Because these days, if you could see on TikTok the videos that they are making here in South Africa, I'm like, I can't even do half of the dance that they're doing. Complicated.
Definitely. All right, well done, everybody. Okay, so that was out of 6 marks, wasn't it? So I guess here there would be a mark for subbing in, standard form factors, 1, 2, 3, 4, 5. I wonder what else they would have, maybe they would have given us a mark for writing T as 2S plus 1, which was such a lovely idea. Ma'am, you just have to move your body in. That's it. Can you see there? Quite right. Okay, good job, everybody. Lovely. All right, well, I hope you enjoyed working through that question. We've still got 20 minutes, so let's go and have a look at this question over here. This is a little bit more difficult than the previous one, but same idea. I don't know if we'll get all the way down to the bottom, but let's see what happens. Okay, so here we have got quadrilateral. Notice they say quadrilateral, guys. They don't say that it is a parallelogram or anything like that just yet. Quadrilateral A, B, C, D. A has coordinates x and 3, B has coordinates 1 and 0, C has coordinates -2 and -5, and then there's point D. E is the midpoint of AC, all right, and AC cuts the x-axis at F. AFB is theta, FBE is alpha. All right, what are they asking us to do? Okay, so in 2.1, they want us to calculate the length of BE. And in 2.2, they want us to calculate the gradient of BE. So those are 2 really simple, straightforward questions. Let's do those quickly, and then we can get on to the rest of the questions, hopefully. Okay, so you guys do 2.1 and 2.2. Share your answers when you're done. Okay, so Kanisile says the distance is root 17. Anybody else getting the same answers? Kanisile? Cool. Okay, Lena, nice. Well done, Kulani. Root 17. Gradient of BE next. Me too, can you see? I'm also getting 1/4 as my answer. Okay, so these sorts of questions, matrix, we really should be able to whip through so quickly now. So accuracy, accuracy, well, sub-accuracy, sub-accuracy. There we go, lovely. Okay, Chiamo, you're getting the same answers as us. Great. All right, 2.3. Determine the equation of the straight line parallel to BE. Well done, Spare. And passing through C. So this is now out of 3 marks. Determine the equation of the straight line parallel to BE and passing through C. All right, so lines that are parallel, what can we say about them? What characteristics do parallel lines share? Exactly, Lena. Okay. They have the same gradient. Good, Kanisile. Okay, so we know what the gradient of BE is. We've just got to now use the coordinates at C to work out the y-intercept of this particular line. Okay, can I let you guys do that? You can share your answer when you're done. So share your answer when you're done. Can you see that you are on fire, girl? If this is how well you can do maths, imagine what you're going to do with Mr. Bavuma and those dancing lessons. Hey, it's going to be amazing.
Yeah.
You're a lucky man, Mr. Bavuma. That's all I can say. Sorry, dropping things here. Okay. All right, so you're both getting the same answer there. So 2.3. Let's just stick this on the side over here. All right, so the next question, they want us to show by calculation that x is equal to -4. Okay, so x is this one up here. Remember that E is the midpoint of AC. I'm sure they told us that at the beginning. Yes, E is the midpoint of AC. They told us that over there. So how would we show that x equals -4? That's good, Kanisile. Okay, so I'm just doing the answer to the previous question. How would you guys show that x was equal to -4? What formula are we going to use? Midpoint formula. 100%. Okay, so we're going to use midpoint formula. We're not allowed to sub in the -4. Okay, so our previous answer, quite right. And then in 2.4, we would have used midpoint formula as Kanyisile had suggested. So we would have said that x minus 2, because we're using this point over here, over 2 is equal to the x coordinate at the midpoint, which is -3. We would have cross multiplied, and x minus 2 would be equal to -6. And then we would add 2 to both sides, and therefore x would be equal to -4. Okay, that's it. Okay, good stuff, everybody. Well done. That wasn't so bad. Show by calculation that AC is perpendicular to BE. So what do they want us to do here? Show by calculation that AC is perpendicular to BE. How would we do that? What would we do here? What are your suggestions?
Ma'am,
Yes.
for this question, wouldn't we find the gradient of AC and then say the gradient of AC times the gradient of ED is equals to -1?
Okay, you're on the right track. Absolutely. So what we would do is that we wouldn't start off assuming that the product of the gradients was -1. What we would have to do is we'd have to work out the gradients, then multiply them together, get -1, and then say that the lines were perpendicular to one another. Okay, so, but yes, you are absolutely on the right track. Okay, the product of their gradients, if it gives us -1, then we know that we have done the correct thing. Okay, so now let's go ahead and go and do that. We already have, so this is 2.5. We have got the gradient of BE, haven't we? All right, so we know what that is from 2.2. We know that it's equal to 1/4. All right, so let's just write that down. The gradient of BE is equal to 1/4. Let's work out the gradient of AC. So the gradient of AC next. So that is going to be 3 plus 5 over, and then x is equal to -4. So it's -4 plus 2. Did I do that right? Yes, -4. Yeah, -4 plus 2. Okay, which leaves us with 8 over -2, which leaves us with -4. So now, Kanyisile, what we would do is this. We would take 1/4, we'd multiply it by -4, and we would end up with -1. Okay, and now we can say that the gradient of BE times the gradient of AC equals -1, and therefore BE is perpendicular to AC. Okay, yes, Lena, quite right. Okay, good job, everybody. Okay, we're nearly there. Okay, we'll just do these last 2 questions and then we're done. All right, now calculate. How many marks is it out of? Good question, can you see there? 3. 3 marks. Okay, so I would say a mark for that, a mark for that, and a mark for your conclusion. Okay, perfect. Okay, calculate theta, the angle of inclination of AC. Okay, well, that's easy enough. Calculating an angle of inclination, we would use tan theta equals m. Since we already know the gradient of AC, we know that it's equal to -4. So in this situation here, 2.6, we know that tan theta is equal to -4. Okay, so remember what we've got to be careful of here is that our angle of inclination is obtuse. So I don't know what your teachers at school show you to do, but we show our boys to calculate an RA first. You don't have to do it this way. You can work out what the angle, the negative angle is, and then add 180 degrees to it. Or you can subtract your RA, which in this case is 75,96. So theta is equal to 180 minus 75,96. And that would leave us with 104,04. Okay, it's just really important, guys. You cannot write that theta. Okay, so it's not theta that is equal to 75.96. You'll be penalized if you do that. Okay. So your alternative here would be to say that theta is equal to negative 75,96 plus 180. But you cannot say that theta is either 75.96 or negative 75.96. Okay, 104,04 degrees. Okay, last question, and then we'll leave it there. We've only got a couple of minutes left anyway. All right, last thing, guys, calculate the area of triangle FBE. That's out of 5. Area of triangle FBE. So here is triangle FBE. I'm going to color it in. There you go. What do you guys think? How would we do that? There certainly is more than one way. What do you guys think? All right, well, we don't have a lot of time, so let's just jump into it. All right, there's 2 ways you can answer this question. All right, when they ask you to calculate the area of a triangle, either you can use the area rule from trig, or you can use half base times height in this case as well. Okay, so you know that the length of EB is root 17. You do. What I would do here, yes, can we see that? And you can work out the length of FB as well. So what you'd need to do is you'd need to work out the coordinates of F. And then you could work out the length of FB. Then you'd need the size of angle alpha, because the area rule is side angle side. You know what I would do here? This is what I think would be easier in this regard, because I suppose you could work out if it passed through there, and then it would be vertically opposite angles. Okay, what I'm going to say to you is, why don't we do this? Why don't we do half base times height? All right, so in other words, let me redraw the triangle over here. All right, so you've got F, and then E is over here, and then it's somewhere like that. Okay, not 100% perfect. F, E, B. So here's F, here's E, and here's B. Okay, you know that at E, the coordinates are -3 and -1. At B, you know that the coordinates are 1 and 0. Whichever method you choose, you have to know what the coordinates at F are. All right, that's your first point. So F is the x-intercept of AC. Do we know the equation of AC? No, we don't. Okay, but we know that the gradient of AC is -4, don't we? So we can work out the equation of AC. So y equals -4x plus c. We know that AC passes through C, so that's -5 and -2. So -5 -2. And then that means that C is going to be equal to -13. So y equals -4x minus 13 is the equation of AC, and F is the x-intercept. So for the x-intercept, we would let y be equal to 0. All right, so taking that over to the other side, we would end up with 4x equals -13. So x would be equal to -13/4. So therefore, the coordinates at F are -13/4 and 0. Now what we can do is we can calculate the length of FB, DFB. Because what we can do is we can use this line over here as our base. And then what we can do as well is if we can use this line over here as our perpendicular height. So we'll just go up and go and have a look at the diagram. Can you see that point E is at -3 and -1? So that means that point E is exactly 1 unit away from the x-axis. Does that make sense to you? E is 1 unit away from the x-axis. That would be its perpendicular height of triangle FBE. Does that make sense to everybody? Okay, so based on the coordinates. All right, so now we just want to work out the length of the base. So this is a little bit of a nasty one. So here we've got -13/4 as our x coordinate, -1 squared plus mind you, this is a horizontal line, isn't it? So we actually don't even need to do that. We can actually just say that FB is going to be the x coordinate at B minus the x coordinate. Okay, which would be even quicker. We could do it that way, but that'll be even longer. So this is going to leave us with 17/4. So that is the length of FB. Therefore, the area of triangle FEB equals half base times height. So this gives us half 17/4 times 1. Okay, so that leaves us with 17/8 units squared. Okay.